Hello friends, this is second video lecture on Bessel's function. I have already made one, link is in the description box. Okay, here I'm going to show you how to prove this formula, recurrence formula. Here, this is formula number 1, and using this formula, how to solve this question. I'm going to show this how to solve this question. This was asked in NET exam June 2023. Okay, so this question was based on this formula. Okay, so first let me show you how to prove that. So before we proceed, please do subscribe the channel, hit the thumbs up button, also share with your friends, inspire me to create new contents for you and help me to grow my channel. And if you want to follow me on Insta, this is my Insta ID OJHALAKHYAJIT123. that's my Insta ID 123, right? So now let's start. So first let me write the formula. So here is the formula. So now let me tell you one more thing. This ZSN, what does it mean? This means nothing but ddx of Zn of x, right? Okay, this is what does ZSN mean. Okay, I'm talking about this term. So now let me show you how to prove this. Okay, so we know the Bessel's function, which is given by Zn, which is equal to summation from r is equal to 0 to infinity minus 1 to the power r by r factorial and gamma of n plus r plus 1, okay, and x by 2 whole to the power n plus twice r, right? Now let us differentiate both sides in order to get the Zn dash. Okay, so let me differentiate with respect to x, then we get Zn dash. What does it mean? That means ddx of Zn, right? And on the other side, what we're gonna have, let me write the result first, then I'm gonna explain here what and how we have got this. So now here you see, so here you see, so this is here is the power n into 2 to n into twice n plus twice r. So on differentiating, this power comes here and the power minus 1, right? So hope you have understood this. That means we have applied this ddx of x to the power n, ddx of x to the power n, which is nothing but n into x to the power n minus 1. But instead of x, we have x by 2, so we need to differentiate it again, function of function. If you differentiate x by 2, then you're gonna have half here. Okay, so hope you have understood this. So now here you see, okay, so now what we're gonna do, we're gonna open this bracket, right? That means the whole term will be multiplied with n in then plus then twice r. Okay, so right, so let me simplify that way. So this n is this one here multiplied by this minus 1 to the power r divided by factorial r gamma of n plus r plus 1 and x by 2 whole to the power n plus twice r minus 1, then into half. Then again it should be multiplied by twice r. Again it should be multiplied by this twice r here, you can see. Okay, and this time what we're going to have plus summation minus 1 to the power r factorial again gamma of n plus r plus 1 x by 2 whole to the power minus 1, then we're gonna have half here. Okay, then let's multiply that twice r here. This is the twice r. Okay, so here this term is nothing but n plus twice r, right? So n plus twice r. Okay, so except this term, this whole term is multiplied by n and twice r if you open this bracket, right? So that means, let me show you something. So here you see, just give me a second. Okay, this term you can write, this is into this whole term, right? You can write this way. Then if you multiply, if you open this bracket, then what you gonna get? This whole thing is multiplied by n, then whole thing is multiplied by twice r, and doing so we have got this, right? So now you see, let me copy this step and let me go to new slide. Okay, let me take a new slide. So this is the last step. Let me rewrite the last step here. Okay, so this is what we have got in the previous slide. Okay, so now what we can do here, let's multiply both sides by x. Okay, so here you see we have multiplied here x, and this is also x, and here also x, with all the three terms, this one, and this one. Here I should write z as n, right? Z as n. Let me go back to the previous slide. So here also I forgot to write the dash. Give a dash here to represent this ddx of jn. Okay, so now let me go to the next slide again. Now here you see, let me cancel this 2 by this one, and what we can do, we can multiply this one and this one. Then what we're gonna have, so here we have x by 2 whole to the power 1. Okay, x by 2 whole to the power 1. That means if you multiply this two, then you should get x by 2 whole to the power n plus twice r minus 1 plus 1. That's gonna be x to the power, sorry, x by 2 whole to the power n plus twice r. And this r recurring can be written as r into r minus 1 recurring, right? So that's why this r and this r will be cancelled. Okay, so now let me write it. Let me clean this first. Okay, so let me write it. Let me write what we're gonna have here. So we will get x, z, and this, right? Then here, sorry, so this is what we have got. Let me show you. So now we have got this, right? If you multiply this one and this one, okay, then again this r cancels r recurring to give r minus 1 recurring, right? So that's why it will be of this form. Let me show you here. X summation, okay, 1 minus r to the power r, sorry, 1 minus 1 to the power r, then r minus 1 recurring, then gamma of n plus r plus 1, right? Gamma of n plus r plus 1, then x by 2 whole to the power, let me write this one properly, x by 2 whole to the power n plus twice r minus 1. That's what we have got, right? Okay, now just give me a second. So let me write it properly, n plus twice r minus 1. Okay, now you see here this part is nothing but the Bessel's function, right? So let me go back to the previous slide. Here you see this is the Bessel's function, this is, right? So let me copy this Bessel's function, okay, and let me go to the next slide. This is the Bessel's function, right? Okay, if this is the Bessel's function, so then what we get, let me copy this. Here you see, so here you see this is the Bessel's function, right? So here you see, if you compare this term, so here you can see clearly this can be replaced by jn, right? So now let me clean this first. Okay, so instead of this we're gonna write jn, this part, this is the jn Bessel's function, right? So hope you have understood this. So here we're gonna have n into jn, right? Okay, because here you see this is the Bessel's function, right? This is the Bessel's function. Here we don't have n here, any n, so this is n into this Bessel's function jn, right? So now let me cut it first. Okay, so let me rewrite the relation x, j, and this is equal to n jn. Okay, just give me a second. Let me give this equation number 1 so that I can write here using equation number 1 plus. Now okay, let me copy the second term here and paste here. Okay, this is the second term of this relation. So here we're going to write using 1. Okay, now what we can do, now let me replace r, let me replace, sorry, not r minus 1 by s, so that we can write r is equal to s plus 1. Okay, in this in the above relation. Okay, so first let me copy the last step and then let me go to the new slide. So here you see, so now what we're gonna do, we're gonna replace, just give me a second. Okay, so here you see, so let me replace this r by s plus 1. Okay, let me write here s plus 1, then r minus 1 by s, let me replace this one by s, then here you see 2 into r will be replaced by s plus 1, here we have minus 1, that's what we're gonna get. So if you simplify this power, n plus twice s plus 2 minus 1, so that means it's gonna be equal to, this is gonna be equal to n plus twice s plus 1, and it can be written this way. Let me write this one, 2s n plus 1 plus 2s, we can write this way, right? So let me, okay, and similarly replace this r as well, then you're gonna have s plus 1, so you can write this in this way. Let me show you. So if we replace this r, then okay, now let me replace this r by s plus 1. So if you rearrange this term, you can write this way. Okay, you can write this way, n plus 1 plus s plus 1, you can write this way. Okay, so n plus 1, here it is, n plus 1, okay, plus s plus 1. Now here you see, if you compare these things with the Bessel's function, let me copy the Bessel's function. So as I have already written these two steps in the previous slide, here you can see, so you don't need to repeat those steps again. Just as I have changed the slide, so I have written these steps again to continue the next step. So let me cut this and let me write this one on top. So now if you see the Bessel's function, this one, equation number 1, let me copy this again so that we can compare the result. Here you see, this is Bessel's function. So now you see, you can compare this one, this s factorial with r factorial, right? And here you see, and one more thing, let me write this one here. You see, this is minus 1 to the power s plus 1, so you can write this way. Just give me a second, let me copy this, let me repeat this. So here you see, this can be written, this term, I am talking about this term. Here you can see minus 1 to the power s plus 1, it can be written this way, minus 1 to the power s into minus 1 to the power 1, and minus 1 to the power 1, that's going to be minus 1. So what you can do, you can make it negative, this plus symbol can be made negative, right? So hope you have understood this. So here we have got again minus 1 to the power s, here we have got minus 1 to the power s. Now you can compare this term with this minus 1 to the power r, and you can compare this n with this n plus 1. So this is Jn, so as instead of n we have n plus 1, right? So that means you see, in this Bessel's function, here you see, in this Bessel's function, let me show you. If you see, so you can consider this way. So instead of n you have n plus 1, and instead of r factorial you have s factorial, right? So you can consider that way. So if you replace this r by s, this r factorial by s factorial, then n by n plus 1, so s by, so r by s, here it is s, and replace this n by n plus 1, so then this will be j n plus 1, right? So hope you have understood this. So that's why we can write this is n plus 1, and here we have x also, right? So it's gonna be equal to x into j n plus 1, right? So that's why we can write the next step now, that is x into j n dash n into j n minus x into j n plus. So this is the recurrence formula, formula 1, that we need to prove. So this one is proved. Okay, so now let me take a question which can be solved by using this formula. Okay, here is the question. Let me write the Bessel's formula first here. This is the formula that we're going to use. Okay, now what is the question? If the Bessel's function of integer order n is defined as this, so then the derivative of this will be equal to, so which option is correct? Now you see ddx of x to the power minus pi j pi of x. Now let me write this formula in terms of pi instead of n. So then what we can write? X to the power j pi this is equal to pi j pi minus x j pi plus 1, right? We can write that way. Now you see, so here as we have minus pi, let me multiply x, let me multiply both sides by let me multiply both sides of this formula by x to the power minus pi minus 1, x to the power minus pi minus 1. On this side also let us multiply x to the power minus pi minus 1, and here also let us multiply x to the power minus pi minus 1. Okay, so hope you have understood this. So why I did this? Because you see, if you multiply x to the power minus pi minus 1 into x, then you will get x to the power minus pi, right? So here we have x to the power minus pi, that's why we have done this. Then this is going to be equal to x to the power minus pi j pi this is equal to x to the power minus pi minus 1 pi j pi minus, so again if you multiply these two, then again you will have minus pi j pi plus 1. So here we have this. Now you see, if you differentiate this, what you're gonna have? Let me do this one here. Okay, if you see, if you differentiate this, then what you should get? First function, that is x to the power pi minus j, and derivative of the second function, that means j pi dash, right? Then plus u into v rule is being applied here. Okay, then plus second function, that is jn. Okay, then derivative of this is minus pi x to the power minus pi minus 1. So you can make this positive negative, right? So that is what we have got. Now let us obtain let us try to obtain this. Okay, so here you see, here we have this x to the power, okay, minus pi, okay, and here x to the power minus pi minus 1, right, into pi. Okay, so then what we can do here, let me transfer this part, this pi into j pi n, let me transfer this part to this side. Then what we're gonna have? We're gonna have x to the power minus pi j pi dash minus x to the power, let me write the pi first, pi then x to the power minus pi minus 1 j pi is equal to minus x to the power minus pi j pi plus 1. So now you see this is nothing but this one, which is equal to this one, right? So that's why what we can do now, let me clean this first. So now here you see, therefore we can replace this part by ddx of x to the power minus pi j pi means j pi of x actually is equal to, on the other side we have got minus x to the power minus pi j pi plus 1. So here actually j pi plus 1 of x. So where now you see this formula actually that we have used. So what was the formula? So in this recurrence formula also that we have used to prove this, we have x here, jn dash of x, jn of x, jn of x plus 1. So we don't used to write this x each and every time. Okay, so hope you have understood this. So that's why here this x is written. So this is the option D. So our correct answer is D. Okay, so answer is option D. This is the correct answer. This is option D, right? So hope you have understood this. So thank you for watching. See you in the next video. Bye bye.